Hello everyone, let's solve Leetcode 1239 maximum lengths of a concatenated string with unique characters. You are given an array of string array, right? A string S is formed by the concatenation of a sequence of array that has unique characters. Return the maximum possible lengths of S. A subsequence is an array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements, right? So let's take the first example. So as you can see that in the first example, we will have these three characters, right? So let's take the first and the second, right? We're gonna have U and IQ, right? These characters, all of them are unique, right? So the length is gonna be four. So what if we take all of them? If we take all of them, you can see you will be duplicate, right? So is this not going to be the right subsequence, right? So what if we take the second two? I and the Q, right? It's gonna be IQ and UE, right? It's gonna be this one, right? And all of them are not duplicate, so it's gonna be four, right? The length is gonna be four. So how do we solve this problem? Let's see the constraint, right? As you can see, the length of the array is gonna be 16, right? So we can solve it in brute force, right? We can brute force the solution, right? So to solve this problem in brute force, we can use backtracking, right? So how do we solve this using backtracking? To solve this problem using backtracking, one thing we can do is we can start from let's say the first index. I mean from the first string. Let's say UN, right? So we will take UN or we just use we will take it or we are not going to take it, right? Let's say we are going to take it, right? It's gonna be UN, right? And we can our index is gonna be here, right? And but what if we are not going to take it? So we're gonna have empty string, right? We're gonna have an empty string, let's say. So at this point, let's say we are going to take IQ, right? It's gonna be all the concatenated strings. We're gonna have this, right? It's gonna be this one, right? We have this, and what if we are not going to take them, and we will remain with UN, right? And at the last one at index three, we're gonna have we take all of the characters, right? But you since UN is gonna be repeated, we are not going to take um, UN, right? Because U is gonna be duplicate, right? So we will have U and it's gonna be the one at index, the state as index two is not the string is not going to change, right? But only the index, right? But at this point, also at index three, also we're gonna have U and this gonna be unique, right? This gonna be we're gonna have this string, right? So since we are at the end of the array, since we are at the end of, we can just check, we can maximize the lengths we have so far, and we backtrack, right? We pop it from our present, we backtrack, and we backtrack from we will pop this. We will pop once we have when we backtrack, and we're gonna be in the color, right? So for this one also we're gonna have four, so the length is gonna be four so far, right? And we backtrack, right? Then once we are at this position, since we just return first, right? But we will go to this way, right? And we will take UN with the next index, right? The next index at let's say if we take if when we are at this point, we will take the next index, right? The next index is gonna be three, right? And the character we are going to take at index two is gonna be UN, right? And yeah, it's gonna be okay. So the character we are taking is UE, right? So since U is gonna be repeated, become duplicate at this point, also we are not going to take it, and it's gonna be UN. Since the length of this one is gonna be and as index three is also this one is gonna be UN, right? And since the index is gonna the length is gonna the length is not going to change, right? UN, the length we have so far is four, but at this point the length is two, right? So the maximum length so far is gonna be four. But what if we are not we didn't take the one at index let's say we are at index 2, right? Let's take then the character at index 2. I mean at index 1, right? It's gonna be 1. So at index 1 is gonna be IQ, right? We will take IQ, and we are not taking it. We just skip this one. And so I think just what we are going to at each step is we will pick a certain number or not. We are not going to pick a certain string, right? So once we reach our once we recurse to the end, we just uh, we will maximize, right? We maximize the maximum links we have so far, and we return, right? We backtrack. So the time complexity for this one is to the power of n, right? It's gonna be the time complexity is gonna be to the power of n, and the space complexity is gonna be the depths of the space complexity is just since the code stack is gonna be the depths of um, the depths of the recursive algorithm. So it's gonna be of n the space complexity, right? But the time complexity is gonna be to the power of n. So let's go to the implementation. And since let's say we have n, right? N is the length of the array, right? And let's say we have a backtracking function, right? Let's say we have a backtracking function. We have an index, and let's say we have a path. So once our index is gonna be our index is gonna be greater than equal to n, we have to backtrack, right? We have to let's check first this one, and once we are at this position at this state, what we're going to do is we will maximize, right? Let's say we have a global or non-local max length variable. Let's say we have this, and let's make it non-local, right? Non-local, we make it global, right? So max length, and we will maximize this max lane, right? Max lane is gonna be max of max lane, and and the paths we have joined the paths, we have converted into a string. Since this is since I'm going to use an array, so I'm going to change it to a string, and what I'm going to maximize is a length, right? So I'm going to use length. So I'm gonna maximize the length, and it's gonna be yeah. So I'm gonna have this one, right? Once I have done this, I have to check if let's say let me define another function which checks the 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 path is unique, right? The path has unique characters. So is unique. Let's have a function which I'm going to give it a path. So it checks whether the path is unique or not. So if first let me concatenate all the characters, right? So where I can say like return set of if the length of the set, if the length of the set is just is gonna be let me join them, join the paths. If this is the same as the length of the paths, it's gonna be all of the characters are unique. It means all of the characters unique, right? And also we have to join this one, right? So once it has to be joined, right? Joined, and we're gonna have this. So once we have this, it returns true, if okay, if this unique is true, if unique of the path we have and the one we are going to add, right? Let's say we are going to add array at index, right? If this is true, we're gonna add it, right? We can pass would append the, the string at index, right? We're gonna add it to, and we backtrack, right? We will call our backtracking function. So backtrack, and we'll backtrack, and we will backtrack, and then our index is gonna be index plus one and the pass, right? And once we are done, we have to pop, right? Pop from the pass. But what if we this is true, this is false, right? What if it's not? What if it's not unique? So just we backtrack without picking anything, right? We just backtrack, and we increment the index by one, and the path is not going to change, right? So once we are done, we will call our backtracking function. Then what we're going to do is we start from index zero and we'll have a path. The path is just empty, right? Inside. Then we're going to return the max lane, right? Max lane. So so okay, and we have okay. So let's see if this one works or not. So let's test it with the test cases. So it says okay, somewhere it says list index out of range, right? Okay, okay. If index, okay, index is gonna be okay. We start from zero, right? We start from zero. Backtrack if the index is greater than or equal to n. N is the length of the array, right? And we will add this pass with an index, and we will add it to the pass, and we will backtrack and we will copy it from this one, and we will do this one, right? But what is this, the thing that which never, it's never receives condition, right? Okay, so array at index is gonna be, so our index is gonna be at zero. Okay, index is greater than, if index is greater than or equal to n, we just maximize. Oh, we should return, right? Yeah, we have to return because if that's not the case, this is all, the index is not going to be, the index is gonna always increase, right? So as you can see, it passed for the given test cases. So the time complexity is to the power of n, and the space is gonna be the depth of the recursion, right? It's gonna be O of n. So if let's submit this one and see if it works for all of the test cases, right? Okay. So as you can see, it passed for all the test cases. So if you guys like this video, please subscribe because it helps me a lot.